नमस्कार विद्यार्थी मित्रांनो, मागच्या लेक्चरमध्ये आपण डेफिनेट इंटिग्रेशनमध्ये बाय पार्ट्स कसा वापरायचा, पार्शियल फ्रॅक्शन कसे वापरायचे ह्याबद्दलची काही उदाहरणं पाहिली होती. हिअर इज वन एक्झाम्पल. टू इव्हॅल्युएट दिस इंटिग्रल we have to use method of by parts, that is integration by parts, integration of u into v. So we consider this tan inverse x as first function u and x as second function. We treat this tan inverse x as first function u and x as second function v. The rule says keep first function as it is. While integrating u into v, keep u as it is, means tan inverse x as it is, and write integration of second function, integration of v, minus integration of product. In product, derivative of the first function and integration of the second function. Now we rewrite this as integration of x is x square by 2. Here also we write integration of x as x square upon 2 and derivative of tan inverse x as 1 upon 1 plus x square. Okay, so after writing these integrals, we simplify this x square upon 2 into tan inverse x, this x square upon 1 plus x square, this divided by 2, I have taken it outside the integral sign, and now I will evaluate this integral and then make use of these limits. Okay, so to evaluate this integral, I will generate this 1 plus x square in the numerator. So I will add 1, subtract 1. So here 1 is added, 1 is subtracted, and split this into two fractions, means divide this 1 plus x square by 1 plus x square and this minus 1 by 1 plus x square. Okay, so this 1 plus x square upon 1 plus x square, that will give me 1, and this minus sign is written here, and 1 upon 1 plus x square. Now is the time to write actual integral. This minus half as it is, rest of the part I have kept as it is. Only this 1 is integrated and its integration is x. This 1 upon 1 plus x square, its integral is tan inverse x. Now make use of these limits. So we first put x is equal to 1 everywhere. So 1 upon 2, this 1 upon 2, tan inverse 1, then this minus half, 1, tan inverse 1. So I have used upper limit. Now give minus sign and put x is equal to 0. So this whole term becomes 0 if we take x is equal to 0. So that's why the second bracket I have written 0 minus 0. This tan inverse half is pi by 4. Tan inverse 1 is pi by 4. So this half as it is, and in place of tan inverse x I write pi by 4. This minus 1 by 2 is distributed, and this minus plus half tan inverse pi by 4. So by adding these two, half pi by 4, half pi by 4, that is pi by 4, and this minus half as it is, and this is the final answer. So this is answer to the question integration of x into tan inverse x between limits 0 to 1. Though it is problem of definite integration, we have to first evaluate integration, and while evaluating this integral we can use different techniques as per the problem. Okay, now I will just explain one more sum and move to the properties. Today I have to teach you properties of definite integral, but one more problem is there in the slide, so I will explain that problem in short, and I will not go in detail for calculations. Let me read the question. Integration e raised to cos inverse x into sin inverse x upon root of 1 minus x square. So evaluate this, different methods can be used, different substitutions can be used. Here one result from trigonometry is used. That result is sin inverse x plus cos inverse x is pi by 2. So in place of this sin inverse x, I have taken pi by 2 minus cos inverse x and splitted this, distributed this. Actually, before distribution, no, I have made substitution. What is substitution? Cos inverse x is equal to t. Cos inverse x is equal to t. So cos inverse x, its derivative is minus 1 upon 1 plus x square, minus 1 upon root 1 minus x square. Derivative of cos inverse x is minus 1 upon root 1 minus x square. I am reading minus 1, but I can't find that minus sign here. That minus sign is shifted to right side. Here actual derivative of t is dt, but I have shifted that minus sign here. Why? Because I want value of 1 upon this 1 upon root 1 minus x square into dx. So for dx upon root 1 minus x square, I will put minus dt. Now, limits. These are values of x, means initial value or lower limit of x is 1 by root 2. So when x is equal to 1 by root 2, t will be equal to cos inverse 1 by root 2. Cos inverse 1 by root 2 is pi by 4 because cos pi by 4 is 1 by root 2. Therefore, the lower limit of t is pi by 4. Upper limit of x is 1. So when I put x is equal to 1, I get cos inverse 1. Cos inverse 1 is 0 because cos 0 is 1. Cos 0 is 1. So lower limit of t is 0. Upper limit of t is 0. Lower limit is already we have calculated pi by 4. So while writing this integral in the language of t, in place of 1 by root 2, we write pi by 4. And in place of this 1, we write 0. Because when x is equal to 1, t is equal to 0. So these are limits of t. And with these limits, we rewrite this problem e raised to cos inverse x, means e raised to t. This pi by 2 as it is. And minus cos inverse x. So for that cos inverse x, we are writing t. And value of dx upon root 1 minus x square is minus dt. I have used this minus sign to interchange this pi by 2 and t. So I have changed them. Now in the next slide, I have taken this integral and integrated this by using by parts. I have integrated this using by parts. So here I have integrated this using pi by parts. First function as it is into integration of second function minus integration of product. In product we take derivative of the first function and integration of the second function. I will not read these calculations. You may pause this video, keep this slide on screen and read these calculations, or better you work out these calculations and finally check your answer with my answer. My answer may be wrong. Your answer may be correct. So you check these calculations, your calculations, my calculations, what answer I have given here. Okay. Now I will move to properties of definite integrals. ह्या डेफिनेट इंटिग्रलच्या काही छानशा अशा प्रॉपर्टीज आहेत की ह्या प्रॉपर्टीजमुळं आपल्याला इंटिग्रेशन करणं हे खूप सोपं जातं. वी कॅन इव्हॅल्युएट इंटिग्रल्स, डेफिनेट इंटिग्रल्स इझिली, क्विकली. So what are these properties? Let us study. We have given numbers from 1 to 7 to these properties. So we will read one by one. I will give proofs of also. So property number 1 says integration of f of x between limits a to a is always 0. Means if lower limit and upper limit are same, the value of that definite integral is 0. Value of that definite integral is 0. Now, let me write proof of this result. Let integration of f of x be g of x. Suppose integration of f of x is g of x. If integration of f of x is g of x, then definite integration of f of x from a to a, we write it as g of x between limits a to a. Lower limit is a, upper limit is a. First we work out, evaluate this by taking x is equal to upper limit a and then lower limit a. I don't know what is value of g of a, but g of a minus g of a, they will get cancelled. They cancel each other and answer is 0. Answer is 0. So this answer is 0. Here is the answer. So this is simple proof of this property number 1. If what property says, if lower limit and upper limit of a definite integral are same, value of that integral is 0. Now let me move to the second property. Second property says integration of f of x between limits a to b is equal to minus integration of f of x limits from b to a. So if we interchange lower limit and upper limit, the value of the integral changes in sign only. म्हणजे जर आपण एखाद्या इंटिग्रलमध्ये लोअर लिमिट आणि अप्पर लिमिट यांच्यामध्ये अदलाबदल केली तर येणारं जे नवीन इंटिग्रल असतं त्याची किंमत ही पहिल्या इंटिग्रलच्या अपोजिट असते. त्यांचं फक्त साइन बदलतं. म्हणजे पहिल्याची व्हॅल्यू जर 10 असेल, दुसऱ्याची -10 असेल. पहिल्या इंटिग्रलची व्हॅल्यू जर -20 असेल तर ह्या दुसऱ्या इंटिग्रलची व्हॅल्यू बी टू ए वाल्याची व्हॅल्यू +20 असू शकेल, त्याच्या अपोजिट. चला याचं प्रूफ देऊया आपण. सिंपल आहे ते प्रूफ. तर याचं ह्या इंटिग्रलचं प्रूफ देण्याकरता, ह्या प्रॉपर्टीचं प्रूफ देण्याकरता आय स्टार्ट विथ दिस स्टेप. लेट इंटिग्रेशन ऑफ एफ ऑफ एक्स बी इक्वल टू जी ऑफ एक्स. If integration of f of x is g of x, then we can evaluate this left hand side integral. It says integration of f of x between limits a to b, we write it as g of x between limits a to b, and how we evaluate it? G of b minus g of a. I will take minus sign common from this bracket and read it as g of a minus g of b. Take minus sign common and read it as g of a minus g of b. And the g of a minus g of b, g of a minus g of b, I am reading part inside the bracket only. The g of a minus g of b is value of integration from b to a of f of x. G of a minus g of b is value. So this is g of a minus g of b and minus sign outside the bracket. This is value of integral from b to a f of x. So this proves the second property. Now I will explain this property with the help of one example. Actually this is called the verification of the property. So how to verify this property? First we evaluate integration of one function, say x, between limits 1 to 3. Its value comes to be 4. Its value is 4. You can check these calculations. Integration of x between limits 1 to 3 हे 4 येते. Now I will evaluate integration of same function x between limits 3 to 1. I have interchanged the limits, and when I interchange the limits, the value of the integral is -4. Value of integral has come -4. Okay. Property number 3, integration from a to b of f of x dx is equal to integration from a to b f of t dt. So what this property says? This property says integration, in definite integration, the name of the variable is immaterial. In definite integration, name of the variable. In first integral, variable used is x, and in second integral, variable is t. So which variable we use विच लेटर वी राईट दॅट इज इमटेरियल, म्हणजे त्याला काही महत्त्व नाही आहे. म्हणजे आपण सरळ सरळ एफ ऑफ एक्सच्या जागी एफ ऑफ टी लिहू शकतो, साईन एक्स असेल तर त्याचा साईन टी लिहू शकतो, पण डी एक्सचं डी टी करावं लागेल. इथे आपण इंटिग्रेशनमधलं सबस्टिट्यूशन करत नाही, तर ही एक प्रॉपर्टी म्हणून आपण याच्याकडे पाहतोय. याचं प्रूफ अगदी सोपं आहे, अगदी सोपं आहे, काहीच त्याला वेळ लागत नाही. लेट इंटिग्रेशन ऑफ एफ ऑफ एक्स बी जी ऑफ एक्स. So definite integration of f of x between limits a to b is g of x between limits a to b, that is equal to g of b minus g of a. Now I will evaluate this right hand side integral. Right hand side integral is f of t between limits a to b. Integration of f of t is g of t, and therefore its value is also g of b minus g of a. So value of the left hand side is g of b minus g of a. Value of right hand side is also g of b minus g of a. Therefore these two integrals are same. These two integrals are same. Here one problem is explained, but actually there is no need to explain. म्हणजे फक्त इथं cos x चा cos t केलाय, dx चा dt केलाय आणि इंटिग्रल घेऊन दाखवलेला आहे, तुम्ही ते पाहू शकता. फोर्थ प्रॉपर्टी. What this property says? Integration of function f of x between limits a to b. We can read this as integration from a to b of f of x is equal to integration from a to c f of x plus integration from c to b f of x dx, where this number c lies between a and b. c हा a आणि b यांच्या दरम्यान असेल तर आपल्याला f of x इंटिग्रल a to b मधलं हे स्प्लिट करून दोन इंटिग्रलमध्ये लिहिता येतं. We can write this single integral as sum of two definite integrals if c lies between a and b. Now let me give proof of this result. Let integration of f of x be g of x. हे आपलं नेहमीच आहे, integration of f of x is equal to g of x. Now I will evaluate right hand side. I will evaluate right hand side because we know value of this left hand side integral. It is g of b minus g of a. So I will evaluate right hand side integral and show that its value is g of b minus g of a. F of x integral g of x between limits a to c. F of x integral g of x between limits c to b. Now this I write as g of c minus g of a. Then this g of b minus g of c, because upper limit is b and lower limit is c. Here upper limit is c, so c comes first and lower limit is a. Now this bracket is not required because this sign is plus sign. This g of c will get cancelled with this minus g of c, and we get g of b minus g of a, which is the value of left hand side integral. This I can write as g of b minus g of a, and that is equal to value of integral f of x dx, right, between limits a to b. This is left hand side. We can verify this property. आपण ही एक एक्झाम्पल घेऊन व्हेरीफाय करू शकतो, पण त्यात एवढं काही विशेष नाही. म्हणजे हे -1 to 5ला 3 या नंबरच्या ठिकाणी स्प्लिट केलेला आहे, ब्रेक केलेला आहे. ह्या दोन इंटिग्रलची व्हॅल्यू काढलेली आहे, ॲड केली, आणि ती ॲड केलेली व्हॅल्यू ह्या एका इंटिग्रल एवढी येते, हे ह्या एक्झाम्पलमध्ये दाखवलेलं आहे. मला ह्या कॅल्क्युलेशन्समध्ये एवढं काही विशेष वाटत नाही. आय विल स्किप दिस पार्ट. आय विल लिव्ह इट टू यू. यू कॅन वर्क आउट these calculations and then check your answers with my answer. My answers may be wrong. माझे उत्तर कदाचित चुकीचे असू शकतात, तुमची बरोबर असू शकतात. तुम्ही कॅल्क्युलेशन करून पहा आणि मग पहा की याच्यामध्ये काही चूक आहे का. नसेल कदाचित, पण असू शकते, मे बी. चला तर आपण पुढच्या प्रॉपर्टीकडे वळूया. 4 प्रॉपर्टीज पाहून झाल्या. आता आपण 5th प्रॉपर्टीमध्ये आलो. 5th आणि 6th प्रॉपर्टी आपल्याला प्रॉब्लेम सोडवण्याकरता खूप उपयोगी पडते. बाकीच्या पडत नाहीत असं नाही म्हणायचं, पण ह्याचा जास्त उपयोग होतो. व्हॉट दिस प्रॉपर्टी सेज? दिस प्रॉपर्टी सेज इंटिग्रेशन ऑफ एफ ऑफ एक्स बिटवीन लिमिट्स ए टू बी इज सेम ॲज इंटिग्रेशन ऑफ फंक्शन एफ ऑफ ए प्लस बी मायनस एक्स बिटवीन लिमिट्स ए टू बी. म्हणजे लिमिट तेच आहेत, फक्त फंक्शन बदललं. ह्या एफ ऑफ एक्स या फंक्शनच्या जागी जर तुम्ही एफ ऑफ ए प्लस बी मायनस एक्स घेतलं तर त्याचंही ॲन्सर हेच येतं आहे, असं ह्या प्रॉपर्टीचं म्हणणं आहे. म्हणजे जर समजा तुमचे लिमिट 0 to 5 असतील तर एफ ऑफ 5 0 plus 5 is 5. एफ ऑफ 5 minus x, एफ ऑफ 5 minus x ह्या फंक्शनचंही इंटिग्रल तेच असतो असं याचं म्हणणं आहे. आपण याचं प्रूफ पाहू आणि मग एक प्रॉब्लेम व्हेरिफिकेशन करता घेऊ. तर पहिल्यांदा प्रूफ बघायचं आपण. पहिल्यांदा प्रूफ पाहणार आहेत आपण. तर या प्रूफमध्ये मी याच्या अगोदरच्या ज्या प्रॉपर्टीज आहेत त्यांचा पण वापर करणार आहे. I will start from right hand side integral, and in right hand side integral, in place of a plus b minus x, in place of this a plus b minus x, I will put t. So this will become f of t. But this dx will change, limits will change. So when a plus b minus x is equal to t, x is equal to a plus b minus t. Interchange this x and t. So x is equal to a plus b minus t. Now differentiate this. याला differentiate करा. Its derivative dx. Its derivative याचा differentiate घेतला. Minus dx is equal to dt means dx is equal to minus dt. So in place of dx we will have to write minus dt. This will be f of t into minus dt, but limits will change. These are limits of x. So when x is equal to a, when x is equal to a, when x is equal to a implies t is equal to b. x ची किंमत जर a असेल, इथं जर आपण a लिहिला x च्या जागी, तर हा a आणि हा a कॅन्सल होईल and you will get t is equal to b. So I write when x is equal to a, t is equal to b. And when x is equal to b, ह्याच्यात जर आपण x च्या जागी b घेतला तर b कॅन्सल होईल आणि t ची व्हॅल्यू a येईल. t will be equal to a. When x is equal to b, t is equal to a. So when lower limit of x is a, lower limit of t is b, and vice versa. So we write this sum in the language of t as RHS is equal to integration of f of t. We are writing a plus b minus x t. dx is equal to minus dt and limits b to a. b to a. These are limits of t. आपण t च्या भाषेत लिहितो, मग t चं लोअर लिमिट b आहे, t चं अप्पर लिमिट a आहे, म्हणून b to a केलं. हे मायनस साइन जे आहे, हे मायनस साइन आपण ॲब्सॉर्ब करून लिमिट आदला बदल करू शकतो. वी हॅव प्रॉपर्टी दॅट इंटिग्रेशन ऑफ एफ ऑफ एक्स फ्रॉम ए टू बी इज इक्वल टू मायनस इंटिग्रेशन ऑफ एफ ऑफ एक्स बी टू ए. सो ॲब्सॉर्ब दिस मायनस साइन बाय इंटरचेंजिंग लोअर लिमिट अँड अप्पर लिमिट. इथं स्टेट केली ती प्रॉपर्टी, त्याचा इथं वापर केला. नाव आय विल मेक यूज ऑफ that fourth property. Variable is immaterial means we can change this letter t into x, t into x using this property, and this is the integral in the left side. We had started from right side and obtained left hand side. So this proves the property. Property काय सांगते, इंटिग्रेशन एफ ऑफ एक्स या फंक्शनचं आणि दुसरं फंक्शन आहे एफ ऑफ ए प्लस बी मायनस एक्स या फंक्शनचं इंटिग्रल एकाच लिमिटमध्ये जर घेतले ए टू बीमध्ये तर ते दोन्ही इंटिग्रल सेम असतात. मी याच्यावरती एक प्रॉब्लेम करून दाखवतो तुम्हाला. खरं तर त्याचं व्हेरिफिकेशन नाही आहे, हे त्याचं ॲप्लिकेशन आहे. म्हणजे ह्या प्रॉब्लेमचं इंटिग्रल मला काढायचं आहे साइन स्क्वेअर एक्सचं. एक राजमार्ग असा आहे की साइन स्क्वेअर एक्सचं इंटिग्रेशन काढून घ्या आणि त्याच्यामध्ये हे लोअर लिमिट अप्पर लिमिट वापरा, आपल्याला उत्तर मिळेल. पण मी साइन स्क्वेअर एक्सला प्रत्यक्षात इंटिग्रेट करणारच नाही. I will not integrate this sin square x actually. Then what I will do, I will use a little technique, make use of this property and evaluate it. See how I get answer without actual integration. And this is the beauty of property, that without taking actual integrations of definite integral, we can find their value using properties. Let us denote this integral by I. Now use the property. What property says? Value of this integral is same as value of the integral between same limits by changing this variable x to a plus b minus x. So a plus b minus x sin square x च्या जागी sin square a plus b minus x लिहिलं तरी सुद्धा इंटिग्रल म्हणजे आन्सर बदलत नाही, हे आयच असणार आहे. दिस व्हॅल्यू ऑफ दिस इंटिग्रल विल also be equal to integration in the first line. So I is equal to this. Now this pi by 6 plus pi by 3 म्हणजे हा 30 डिग्री, हा 60 डिग्री, 90 डिग्री म्हणजे pi by 2. Or you can take LCM and simplify that. Sin square pi by 2 minus x is cos square x. Sin square pi by 2 minus x is cos square x. So integration of sin square x between limits pi by 6 to pi by 3 is same as integration of cos square x between limits pi by 6 to pi by 3. So we add these two integrals now. आता हे थोडं ट्रिकी काम आहे. हे दोन इंटिग्रल जे आहेत ना माझ्याकडं, हे इक्वेशन नंबर 1 आणि इक्वेशन नंबर 2, I will add them. So adding 1 and 2, in left side I get I plus I 2I and integration sin square x plus integration cos square x. You can take them under single integral sign and write sin square x plus cos square x. But value of sin square x plus cos square x is 1. So I have to just integrate 1. I have to just integrate 1. That will give me value of 2i. So 2i is equal to integration of 1 is x between limits pi by 6 to pi by 3, which is equal to pi by 3. I have used upper limit pi by 3 minus lower limit pi by 6, and the difference is pi by 6. So 2i is equal to pi by 6, I is equal to pi by 12. Pi by 6 divided by 2, that is pi by 12. So without actually integrating sin square x, I have obtained the value of its integral. म्हणजे प्रत्यक्षात इंटिग्रेशन sin square x चं इंटिग्रेशन न करता आपण हे उत्तर मिळवलं. आपलं इंटिग्रेशन कोणाचं करावं लागलं? 1 चं इंटिग्रेशन करावं लागलं. हे पर्टिक्युलर टाईपच्या प्रॉब्लेम करता आपण ह्या प्रॉपर्टीज वापरू शकतो. आणखी काय प्रॉपर्टीज आहेत त्या पण प्रॉपर्टीज आपण पाहणार आहोत. त्याच्यावरचे एक्झाम्पल आपण करूयात. 6th प्रॉपर्टी आहे इंटिग्रेशन ऑफ f of x limits from 0 to a. We can read it as integration from 0 to a of f of x. Integration from 0 to a of f of x dx is equal to integration from 0 to a f of a minus x dx. म्हणजे मागचीच प्रॉपर्टी आहे ही. काय बदल केला? काहीच नाही. इथं तिथे a to b होता, इथे a plus b minus x होता. मग आता 0 to 1 आला, मग 0 plus a minus x. काही गरज नाही याचं प्रूफ देण्याची. पण जर परीक्षेमध्ये आपल्याला अशीच प्रॉपर्टी विचारली, त्याच्यामध्ये बीचा रोलच नसेल, तर आपल्याला याचंही प्रूफ देता आलं पाहिजे. अगदी सोपं आहे. हे राईट हँड साईडचं इंटिग्रल घ्या आणि याच्यामध्ये पुट a minus x is equal to say t. In right hand side integral, we start with right hand side integral and put a minus x. We put a minus x is equal to t. Now find value of dx, check the limits, find new limits, new values of t and substitute them here. अगदी मागच्यासारखंच प्रूफ आहे, काही सुद्धा बदल नाही आहे. अगदी तसंच प्रूफ आहे. फक्त प्रॉपर्टी लक्षात घ्या. प्रॉपर्टी काय सांगते? इंटिग्रेशन ऑफ f of x between limits a to b is same as integration of f of a minus x between same limits a to b. f of x इंटिग्रल आणि f of a minus x इंटिग्रल हे सेम असतं जेव्हा लिमिट्स 0 to a असतात तेव्हा. मी ह्या प्रॉपर्टीचा उपयोग करणार आहे log of 1 plus tan x इंटिग्रल काढण्यासाठी. I will make use of this property to evaluate integration of log of 1 plus tan x. So let me denote this integral by I and write same integral I is equal to integration of the new function in which x will be replaced by pi by 4 minus x. In place of x, I will write pi by 4 minus x. Same limit 0 to pi by 4. Same function log of 1 plus tan. Only x is replaced by a minus x because of that property number 6. Property number 6. And therefore, now I will expand this pi by 4 minus x, tan pi by 4 minus x. Tan pi by 4 minus x is tan pi by 4 minus tan x upon 1 plus tan pi by 4 into tan x. We write value of tan pi by 4 as 1 and simplify this नंतर याला LCM घ्या, LCM घेऊन ॲड करा, सिम्प्लिफाय करा. दिस गिव्स मी log of this log word as it is and 2 upon 1 plus tan x. Now is time to make use of property of logarithm. Log c upon d is log c minus log d. So this I write log 2 minus log 1 plus tan x. Now I will split this into two integrals. ह्या log 2 चं एक इंटिग्रल करा आणि दुसरं हे मायनस साइन log of 1 plus tan x चं दुसरं इंटिग्रल करा. मग आता आपल्याकडे कसं दिसतं हे इंटिग्रल I is equal to, I will read this part, I is equal to this first integral log 2, second integral log of 1 plus tan x between 0 to pi by 4. But if we observe this is our original integral. आपलाच प्रॉब्लेम आहे हा, आपण ज्याला I ने डिनोट केलं. So I can write I in place of this integral. So in left side I have I is equal to this integral minus I. So let me write it here. I is equal to this log 2 I have taken common minus second integral I have denoted it by I. Now shift this I to this side, I plus I to I log 2 and integration of 1 is x between limits 0 to pi by 4. So this will be pi by 4 minus 0, that is simply pi by 4. So 2i is equal to pi by 4 into log 2 and therefore I is equal to pi by 8 into log 2. झालं. तर ह्या किती प्रॉपर्टीज घेतल्या आपण, 6 प्रॉपर्टीज आणि ह्या 6व्या प्रॉपर्टीवरती आधारित एक एक्झाम्पल घेतलं. 5व्या प्रॉपर्टीवरती पण बेस असणारा एक प्रॉब्लेम पण केला. आता प्रॉपर्टी नंबर 7 आहे आणि त्यानंतर प्रॉपर्टी नंबर 8 आहे. तर ही 7 आणि 8 नंबरची जी प्रॉपर्टी आहे ही मी पुढच्या लेक्चरमध्ये तुम्हाला एक्सप्लेन करेल. 0 to 2a ची जी प्रॉपर्टी आहे ती मी पुढच्या लेक्चरमध्ये एक्सप्लेन करेल. तर आज आपण इथं थांबूया. आजचं लेक्चर इथं थांबते. नमस्कार.